So in the previous video, we have discussed about statistical quality control and also the control chart. So now in this video, we are going to study about process capability. So what do you mean by process capability? The ability of the process to meet design specification for a service or a product is called process capability. So to understand process capability and design specification, first we need to look at some of the terms. That is, what do you mean by nominal value? That is a target for design specification. Suppose you need to manufacture a product of, our target is 15 centimeter, okay? And tolerance means an allowance above or below the nominal value. Suppose it is allowance is given is 15.1 and 14.9. That means we need to manufacture products between these two limits. And process capability is a method of measuring whether we can manufacture within these design specification. So we will define some numbers to show the this process capability. So let us look at this design specification in detail. So just like the last example, we have a nominal value that is maybe 15, and so in this it is given. So 25 is your nominal value, and the upper specification is 30 and lower specification is 20. These are the two limits. So that means we need to manufacture between these two limits. If you manufacture outside this limit, that means that will be rejected, and it shows that the process is not capable. Okay. So then the process distribution. So the process distribution means when you manufacture any product. So suppose our target is 25, let it be meter or centimeter. That means we are producing goods like 25.01 and 24.99, just like that. It will be in a range. So the middle will be 25. Suppose you are manufacturing maybe some 100 products, okay? So that means most of the products will be manufactured around this, okay? And so, and this we are adding 3 sigma, okay? Sigma is the standard deviation, okay? So in order to understand this, we need to understand what do you mean by normal distribution. See, suppose the goods are manufactured, okay? That means the most of the goods, see, if you are manufacturing 100 products, so most of the products will be around this, okay? And some products, okay, will be manufactured, so the limit will go like this, right? And if you plot a chart, then you will get a curve like this. This is called normal distribution, okay? And 99%, okay, 99.73% of products will be manufactured between these limit, that is here 3 sigma on 3 sigma, okay? This is the length, and sigma is the standard deviation, okay? Standard deviation will be manufactured in this limit. That is why we are showing these 3 sigma, okay? It will be between this. There will be some very minute percentage, that means 0.27% will be here, will be in this limit. We are not considering that. We need to check, can we manufacture 99.73% of the products within the 3 sigma limits. So let us see that. So is your process capable of producing 99.73% of its products with design specification limits? So in order to do that, we need to superimpose design specification and process distribution pictures. So let us see. So we have seen our design specification, and this is our process capability. So the process will be manufacturing goods between 32 and 18, and design specification is between 30 and 20. Clearly, many of the products does not meet the design specification weight, and these are called defective products, and that will not be accepted by the customer. So that means here the process is not capable. Okay, it is not able to manufacture 99.73 percentage within the design specification. Maybe it is able to manufacture maybe some 70 percentage, but that is not sufficient. We need to manufacture 99.73 percentage of the goods within the design specification. Okay, so how will you measure the process capability? Process capability is given by the number CP. Okay, how will you calculate it? So in the previous example, we have seen the design specification, that is 30 and 20, and the limits are between 32 and 18. Okay, this is our process limit. This is the design specification 20 and 30. So the CP is calculated by using this formula, that is the design tolerance. This is the design specification or design tolerance divided by our process limits, that is 32 minus 18. So it is 10 divided by 14, or it is equal to 0.71. Okay, so that means CP is 0.71. We have seen that this process is not capable. So CP less than 1 indicates the process is not capable. So this is how you measure the process capability. That means this is the tolerance limit of the design, and divided by this is the process the capability, the difference between the specification. That means 99.73 percentage lies between 32 and 18. So next, is the process capability equation still valid when the center of the design specification is not aligned with the mean of the process distribution? So let us understand this with the figure. The answer is no. So this was our correct figure. Here you can look at a capable process. Here you can see that this is the upper specification, design specification. This is the lower specification. Okay, and then so the process is producing goods between these limits, that is 3 sigma and 3 sigma. Okay, this is the process distribution. You can see that now the process is capable because it is 99.73 percentage of the products are manufactured between the upper specification and the lower specification. But now let us come back to our question. Here now our design specification nominal value is here, and lower specification value is here, and upper specification value is here. Now but our process is like that, it manufactures around this mean. Okay, it is manufactures mainly around this mean, with the process spread over like this, okay, to this limit. Okay, so now is the process capable. From this figure we can easily identify that this is not capable because these are all defective products. Okay, because our design specification is the upper specification. If your process is manufacturing goods above this upper specification, this area, so that is not acceptable and that will be rejected. That means the process is not capable. Okay, now but we have seen that the process capability can be measured by the number CP. If you calculate CP, okay, if you calculate this CP, sometimes even in this case the process is not capable, still CP can be greater than 1. Okay, because the mean is not coinciding with the nominal value. And how will you measure the process capability in this case when the mean is not coinciding with the nominal value. In that case, we will use a different number, that is CPK, or process capability index. So this is the minimum of mean minus lower spec by 3 sigma and upper spec minus mean by 3 sigma. Okay, so these are our nominal value. This is lower specification, this is upper specification, but the product process is manufacturing around this mean. It is up to this limit it is manufacturing, these two limits. Okay, so now let us substitute the values and let us find out. So here CPK is minimum of, you can see that our mean process manufacturing mean is 28 minus 20. Our limit was 20. Okay, so our lower specification limit was 20. This is not given there. Okay, so now the minimum of 28 minus 20, this is the lower specification limit, this is the mean of the process, by 28 minus 21. Okay, and or 30 minus 28. So here the upper specification limit is 30. Okay, 30 minus 28 divided by this 3 sigma, that is 35 minus 28. So you will get value as 8 by 7 and 2 by 7. We need to take the minimum. So minimum value is 2 by 7. It is less than 1, which shows that the process is not capable. So that means if you calculate CP, so if you just calculate only CP, then that means it may be capable, it can be greater than, but CPK, this is the correct number. It shows that it is less than 1, that means process is not capable. So what is the difference between this process capability and process capability index? So CPK can be used with no caveat. That means this is a general number. You can use it anywhere. But CP can be used only when mean of the process distribution and center of the design specification width are aligned. So that is the difference between CP and CPK. So CPK we will use when the mean and nominal values are not aligned. So let us see once more what is process capability. Process capability refers to the inherent ability of the process to produce similar parts for a sustained time under given set of conditions. So this is the definition of process capability. So we can use CP and CPK as a process capability metrics. Okay, and PP and PPK, these are process performance metrics. These are similar to CP and CPK, but these are used in the long term. Okay. So that means you can see here, see if you look at here, that means that this refers to a process. Okay, we are seeing whether the process is capable. We will calculate CPK etc, and we will see whether the process is capable. You can look at another process also and we will see it is capable or not. But process performance means you are running several processes throughout the time, maybe through 1 year. Okay, and we will measure the CPK throughout. Okay, based on that we will find PPK. So if it is within the limits, see, All these process can be correct, but this process here the CP can be less than 1 in some cases. So this PPK, process performance measure from the customer's perspective. Okay, these are these process performing for a well for a long, if you consider a long period of time.